All right, so we'll do this together now. So for this one, again, we somehow want to eliminate a variable somehow, right? We want to do that, and we're using elimination to solve this. Well, before I even get to the next slide, right, looking at the coefficients here, for x, we have 5, and for this one, we have 3. But, we really can't multiply 3 by a nice number. We cannot multiply 3 by an integer or a whole number, I guess, to get -5, right? And we really can't multiply 5 by a whole number to get the 3. -3, I mean. So 5 and 3, let's come back to it only if we have to. However, if we looked at y, here we have -1 and we have a 2 here. Well, that's a lot nicer than 5 and 3, right? Because we know that if we multiply the top by 2, the top equation that is, then we will get -2y on top and 2y here, and those will cancel. And that's actually what I do. So what I was trying to show you is, looking at the equations, you may have to make a choice, so to say. Do I eliminate x? Do I eliminate y? Which coefficients are easier to work with? What I was trying to show you just now is, well, looking at the coefficients of y, they seem easier to work with. So let's eliminate y. And that's what I'm doing here. I'm multiplying the top by 2, as you can see. Right? And then we add, right? I mean, sometimes it might take a little trial and error, just looking at it for a bit, which variable should we eliminate? But you can see by looking at the coefficients of y, well, that's going to be a lot easier to eliminate. You could eliminate x if you want to, but, might take a little more work. So from here, we have -2y and 2y. So they're going to, if we add, they're going to vanish, and that's what happens here. Here, we get 10x plus 3x, which is 13x, right? Because we multiplied the whole equation by 2. Okay? So we have 10x, right? And here we have 10. So we have 10x plus 3x is 13x. 10 plus 42 is 52. Okay, that's good. Right? That's good. So we have that equation, but it's only one equation in one variable, right? That's a lot easier to eliminate, to solve, excuse me. Right? Namely, all we do is we just divide by 13 and boom, we get x. We know x has to be 4. Now, we can use either of these two equations once we get x to get y. So I'm using the first one. Right? I replace x by what we got, and why does x have 2? 4. Did I make a mistake? Yes, I did. Oh, I can fix that. So x should be a 4. I don't know why I put a 2 here, but that's okay. Let me fix it. So we have 4 here. So 4, that's going to be 20, right? That's 20. 20 minus 1, let me just fix that. That's easy to fix. How did I miss this when I wrote my lecture? Oh, well. So we have x is 4, 20. That's going to be -15. So y should be 15. All right. Okay. Okay. There we go. Much better. Sorry about that. I don't know how I missed that. But anyway, so here we got x is 4. So 5 times 4, right? Well, that's going to be 20 minus y, and we want to get 5. Okay. So that's easy now. What do? Well, we can subtract 20, and we get -y is -15. Right? Dividing by -1, we get y is 15. I don't know how I missed that when I wrote this lecture. Sorry about that. But anyway, this is what we get. So that's our solution. Okay, awesome. Any questions on that? All right. Well, I did have some backup examples, so I figured it'd be good for us to do these. Okay. So let's go through some of these together, okay? So for the first one, so even before we get to it, looking at looking at these two equations, right? Could we eliminate x easily? Well, it looks like we can, right? Because here we have a coefficient of -16, right? Now we know that 8 times 2 is 16. Well, 2 isn't, well, that's pretty easy to get. So let's eliminate x. I mean, you could try eliminating y, but you can't really multiply 6 by a nice number to get 7, right? Or 7 by a nice number to get 6. 8 you can multiply by something to get 16, just 2. So that's what I'm doing here. So I'm going to multiply the first equation by 2. Okay? Multiplying by 2, we get 16x minus 12y is -40. That's the first, the first equation now. That's the new first equation, right? Again, we're using elimination. So now what we can do is add the second one, right? Add the second equation to it, and that's what I'm doing here, as you can see, right? The x's are gone, okay? We have minus 12y plus 7y. That's minus 5y. Over here, we have minus 40 plus 30 is minus 10, right? The negative 20 became minus 40, so we get this. But that's good, because now we have one equation and one unknown, pretty easy to deal with. You just divide here by minus 5, you get y equals 2. So we know y has to be 2 at least. But how can we get x? Well, we can go back to either equation. I go back to the first one, mostly because, as you can see, the coefficients are a little bit easier to deal with, although not much easier. But it really doesn't matter which equation you use. But since y is 2, right, we can get x. I just substitute and solve for x. Right, so I plug it in. See, plugged into the first one. We have 8x minus 12 is minus 20. Adding 12 to both sides, we get 8x is -8. So now we just solve it. We get 8x is minus 8. Divide both sides by 8, we get x is -1. Again, you want to isolate x. And once we get y, the equation becomes an equation in one variable, as you can see. Right? So now you just solve it like we did in chapter 1. You get x all alone. We add 12 to each side. We have 8x is minus 8. I just moved the 8x over here closer, just to make it easier. Divide by 8, we get x is minus 1. So that's what we get here. So the only solution then is -1, 2. Okay. I know I'm not doing the last step of checking, so if you don't do it like on an exam or something, that's okay. And this is the second one. So for the second example, we have 6x minus 12y is 24, minus x minus 6y is 4. I want to make sure I didn't make a mistake. I want to teach well. So again, looking at this though, can we somehow eliminate a variable easily? Well, looking at x, it looks like we can, right? I mean, yeah, this is 6 times x, this is -x. You can just multiply it by 6. And then the coefficient will become -6. So if this so to eliminate x, let's just multiply by 6, the second equation. Then we'll have 6 times x, -6 times x. And that's what I'm doing here. I know you might be thinking, why don't you just multiply the second equation by -2 to get rid of the y? You could do that. You could. But I just chose to eliminate x. But again, generally, if even with elimination, there's more than one path you can take. You could eliminate y, or you could eliminate x. Sometimes eliminating one variable is easier than eliminating the other. So for here, I'm multiplying the bottom by 6, okay? We get minus x minus 6y is 4, right? So again, we distribute. Minus 6 times x minus 36y is 24, right? Now, this is our new second equation, but now it's a lot easier to solve, right? We just add. And if we add, the x's are gone. See ya. When we add the y's, we get negative 48y, and on the right side, we get 48. But we want y, right? But now we have one equation, one unknown. Like so. So we just divide by negative 48, and we get y is negative 1. All right, that's cool. So once we know what y is, again, just like before, we can use either equation to get x. And I use the second equation, which makes a lot of sense, actually, right? Because if you look at the second equation, the coefficient of x is, negative 1, which is easier than 6 to deal with. Mostly because it's closer to 0. But anyway, we're running low on time. So let me just show you that basically when you replace y by negative 1, as you can see, you got negative x plus 6 is 4. And now you just solve for x just like before. You get negative x is negative 2. So you divide by negative 1, you get x is 2. Looks like we're almost out of time. All right, so that's good. We have that. So let me stop recording.